In section 12.4, we're covering tangent vectors and normal vectors. The objectives are to find a unit tangent vector at a point on a curve and find the tangential and normal components of acceleration. Here are the definitions for a unit tangent vector and the principal unit normal vector. For both of these, we have C, which is a smooth curve represented by R on an open interval. The unit tangent vector is found by taking the r prime of t vector and dividing by its magnitude. Now the r prime is a tangent vector, so to make it a unit tangent vector, we divide by its magnitude so that this capital T vector is tangent to the curve and it's exactly 1 unit long. Now the definition of principal unit normal vector, again we have a curve represented by r, a vector valued function. Now, as long as the derivative of t does not equal 0, our principal unit normal vector is defined as follows. The principal unit normal vector, it's going to be normal to the curve. It's going to be 1 unit long, and it's found by taking the derivative of that unit tangent vector and dividing by its magnitude. So again, it's 1 unit long. I do have a special note here at the bottom. I do note that n of t, that principal unit normal vector, may involve tedious calculations. In the plane, if the unit tangent vector has components a, b, then the principal unit normal vector is either negative b comma a or b comma negative a, those vectors, but it can't be both. And the principal unit normal vector points towards the concave side of the curve. So it's a little bit of a shortcut there. If you know the unit tangent vector in the plane, then the principal unit normal vector is going to be orthogonal, and you reverse the components and also reverse one of the sides. It has to do with the slopes of if they're perpendicular, the slopes are opposite reciprocals. So if the vectors are perpendicular or orthogonal, the components are opposite reciprocals. Here's an example of finding the unit tangent vector and the principal unit normal vector to the curve given by r of t equals ti plus t squared j, when t is equal to 1. Now you can use a graphing calculator in parametric mode to do a quick sketch of the vector valued function and look at the point when t equals 1. To find the unit tangent vector, we're going to take the r prime of t and divide it by its magnitude. So the derivative of r of t, the derivative of t is 1, and the derivative of t squared is 2t. That's our r prime of t vector. The unit tangent vector is the r prime of t divided by its magnitude. So the r prime of t is your vector I plus 2tj. Dividing by the magnitude is the same thing as multiplying by 1 over the magnitude. And the magnitude of the vector r prime of t is each component squared, add those together and take the square root. So that's how we get the square root of 1 plus 4t squared. So this is our unit tangent vector. You can go ahead and distribute to the I and the j to see another form of the unit tangent vector. Now when t is equal to 1, you can plug 1 in for t into that unit tangent vector formula and simplify. So you get the vector here, 1 over square root of 5i plus 2 over square root of 5j. Here's the original vector valued function, and at the point where t equals 1, you have this vector, its unit vector, it is tangent to the curve, and it is only 1 unit long. The components would be 1 over square root of 5 plus 2 over comma 2 over square root of 5. So you have that little vector. Now to find n of 1, this could be quite tedious, but if you take the derivatives, but there is going to be a shortcut here. It's going to be orthogonal to the unit tangent vector, and it's going to be 1 unit long. So if you know the components here, you can reverse the order of the components and make one of those negative, opposite sign. Okay, if our unit tangent vector is shown here with components, I can write it using the component form and distributing that 1 over square root of 5. 1 over square root of 5i plus 2 over square root of 5j, we would have the components 1 over square root of 5 and 2 over square root of 5. That's your unit tangent vector at t equals 1. Now the principal unit normal vector is either going to be, we reverse the order of the components, and you make one of them negative, or the opposite sign. So it's either going to be this one with where the first one is the opposite sign, or it's going to be 2 over square root of 5 negative 1 over square root of 5. And to determine graphically which one would be your normal, it's going to, principal unit normal, it's going to be pointing towards the concave side of the curve, kind of towards the inside of the curve. It is going to be 1 unit long. In order for you to have a vector that's going to go to the left and up, that first component needs to be negative. So the one that we're going to choose here is the first one, and we can eliminate the bottom one as the principal unit normal vector. Now, if you're not convinced that this is the principal unit normal vector, I would like you to go ahead and use the formula for the principal unit normal vector. Again, if we go back a couple slides, the formula for the principal unit normal vector is to take the unit tangent vector, the derivative of that, and then take the square root of, or take the magnitude, and you can confirm that that indeed would be the correct answer.